Okay, today we are going to model the exponential growth and decay functions. Now, here's your y equals ab to the x. We talked about a being the y-intercept before, but now it's still the y-intercept, but we're going to call it the initial amount. This is what you begin with, is this a. This b is the base, of course, but it's really going to be the numbers that it tells you to be. So meaning that if it says doubling, that would be 2. If it says tripling, that would be 3. If it says quadrupling, that's 4. So that'll be used in these terms. When you are increasing or decreasing it by a percent, don't forget to divide by 100 to get that decimal. And these are now the bases. Those are the bases. So the base will be a decimal, either above 1, like 1.02, or below 1, like 0.98 or something. Okay? All right. So let's go on and look at these word problems and see how we write these out. All right? So in January of 1993, there were about 1,313,000 internet hosts. During the next 5 years, the number of hosts increased by 98%. So we have our timeline here. We have 98%, and we have our initial value, which is the 1,313,000. Okay. So it says, write a model given the number h in millions, that's important, of the hosts in t years after 1993. So we know that we have h equals, and it's 1.313, like the lottery. You got your 3 million hosts, 1,313,000. That's 1.31 million. Then it's, when you take the 98% and you divide by 100, you get 0.98. And then we're just going to raise this to a t because it told me to. All right, there's your equation that you're going to use throughout. I mean, there could be all the way from A, B, C, all the way to Z, just different, years and everything, and you just use the same formula. How many hosts were there in 1996? 96 is 3 years after 1993. So that means that the H is going to equal 1.313, 1.98. That's when you add these together, you get 1.98, and we're going to raise it to 3. This will give us 10.2 million hosts. Okay, you put this in a calculator, it'll give you 10,200, 10,200,000. When will there be 100 million hosts is when you would go to your calculator, and we've done this before. Y1 equals 100, and Y2 is going to equal the 1.313, 1.98 to the x, and then you're going to find the intersection here between these two things. Remember, if y1 is 100, you have to change your y max to 100 so it can go up, and then you find the intersection. So let's actually do that. Let's find the intersection in that one. Let me get to my screen to get my calculator, 84 up, and I will show you. So you go y equals, and then we put 100 in here, and then we're going to put 1.313, parenthesis, 1.98. We're going to raise this to an x, and I'll graph this to show you that I need more. Say I need more. So I'm going to go into my window, and I'm going to change my y max to 100, and then I'm going to graph. And there it is. I don't know if you can see it. Can't really write on this right now, but there it is right there between the blue and the X. Second trace, and then number 5 for intersection. And then I'm going to move this cursor all the way up to right there. 1, 2, 3. Did it do it? I'm sorry. 1 second. Oh, I didn't find my intersection. Hold on, I'm sorry. There we go. There it is right there in the X, 6.3. You see it there on the X? Again, I can't write on this because I moved it. So And there we go, right there, 6.3. So I'm going to write that in there, that the answer to, well, actually it's X or T, is 6.3 years. Sorry, I'm at the bottom of my screen here. Okay, 6.3 years. All right. Moving on to, there are 200,000 bacteria in a sample of water, and the amount doubles every day. So it says write an equation to T days. All right. So our initial amount is 200,000. So we're using this y equals AB to the x. And if you know why I'm using this one and not the percentage, it's because it says the word double. So 200,000 is my A, and then my B is 2. Now I'm using parentheses here because this is going to be raised to an exponent. And remember before, we cannot multiply those two. How many bacteria in 1 week? How many days is 1 week? That would be 7. So y equals 200,000. 2 to the 7. And that gives me 25,600,000 bacteria. Sorry about the slam in there. I don't have as big as a board as I do at school. All right, when will there be 1 million bacteria? All right, so Y1 is going to be 1 million. Okay, Y2 is going to be 2 million, or I'm sorry, 200,000, and then 2 to the x. But to save ourselves a lot of time, what we can do is divide this by 200,000, right? So if we divide the 1 million by 200,000, we'll get y1 equals 2 to the x. All right, what I don't want a million on y1. So I'm going to go back to my calculator, get out of here. I'm going to take the 1 million. I'm going to divide this by 200,000. Again, I don't want 1 million. I don't want 1 million to be my y1. So I'm going to do that. And of course, it is 5. So clearing my here, instead of 1 million, I'm going to put 5. And I'm just going to go 2 to the x on y2. So I'm going to intersect this. So graph. And then second trace 5. Then we're going to find our intersection right there at 2.3, what is that going to be? Days, 2.3 days. Okay, there's our intersection, that big black dot. Okay, all right, so back here, and this is going to be 2.3 days. And yes, you can leave it in decimal form, that's okay. All right, so again, initial value is your A, your base is your double or triple or your percentage. Okay. Ooh, compound interest, this is going to be fun. All about money, okay? So compound interest, we're going to label these real quick for you. A is the amount after everything is done. P is the principal, which is the initial amount, right? That's the beginning. All right, initial amount. R is your percent after you divide by 100. So this is a decimal. T, of course, is your time frame. But it is in years in this particular case because it is about money and it's about interest paid in an initial investment over amount of time in years. Now that N you see up there, N is going to be, I'll write it over here and I'll write it in blue so it's a different color. But N is going to be the amount of times compounding. So, sorry. I got an eraser. 1 second. All right. Sorry about that. So this is the compound value. All right. And those are these guys. So here, N would be 1 because their annually is 1, right? Semi-annually is 2. Quarterly, of course, is 4. There are 12 months in a year, and there are 365 days in 1 year. So these are your compounds. These are your N's in the blue. Okay? So we go to an example, and this really isn't that tough. We just have to label everything. You deposit $1,000 into an account that pays 4% annual interest. Find the balance after 2 years if the interest is compounded quarterly. Let's label everything, okay? So again, I'm going to write down the formula. I'm going to label everything. I'll put in the formula. A equals P is the initial amount at 1,000. 1 plus 4% divided by 100 is 0.04. 4% divided by 100 is 0.04. Divided by quarterly, that's 4. Raised to N, that's 4 times T is 2 years. If you just put this into a calculator, and I'm not going to waste your time doing it for you, you just type it in the calculator exactly as you see it, you'll get $1,082.86. And that will do it. All right. So that's the end of that. You have a worksheet to do, and once you're done handing that in, don't forget to attach it and press turn in. All right. Have a good one. Oh, geez.